In this video, we will talk about factorization. We will be learning how to factorize polynomials, including quadratic polynomials and cubic polynomials. Now, you would recall that when we have an expression a into x plus y, this yields ax plus ay. Now, if we need to factorize this expanded expression, what we need to do is, so if we have ax plus ay, and we need to go the other way. Now, what we need to do is look for the common term of these two terms. And in this case, you can see that it is a. So we write our a outside the bracket. And then we divide the first term by the common term a. Ax divided by a leaves us with x. And ay divided by a leaves us with y. And that's how we do factorization. That's the basic gist of factorization. Now, this is what we would express for other forms of factorization as well. Let's do examples. If we need to factorize these expressions, so if we solve the first one, 5x minus 10, we need to look at these two terms and decide what common factor they have. And if we look, you can see that 5 is common to both of them. We can get 5 from 5x, and we can get 10. We can get 5 from 10 as well. So if we write 5 outside our bracket, so 5x divided by 5 and 10 divided by 5. Now 5 cancels out. 5x is divided by 5 gives us x, and 10 would be divided by 5 to give us minus 2. For the next one, we have x squared plus 2x. X is a common factor. So we have our x right outside the bracket here. And if we do the same for this, x squared plus 2x, and if we divide both of them by x, now x will cancel out one of the x's here to give us x, and x will cancel out the x here to give us plus 2. So we have 2. Now, 15x minus 3x squared. Now, we can be tempted to say that the common factor here is x. But if you look deeper, you can actually see that the common factor is actually 3x, because you can actually obtain 3x from 15x as well. So the common factor here is 3x, and then we'll divide each of this expression by 3x. So if we do that on the side here, 5x divided by 3x. X cancels out x, and 3 cancels out 15 to give us 5. So we'll have 5 here, and minus 3x squared over 3x. 3x cancels out 3x to leave 1x. So that is going to be equal to minus x. For the next one, we have 2 pi r squared plus 2 pi rh. And the common factor here is undoubtedly 2 pi r. Now 2 pi r squared divided by 2 pi r is going to leave us with r. And 2 pi rh divided by 2 pi r would leave us with only h. And so that's the factorized result. Now for this one, 6x squared y cubed and minus 3x cubed y squared. The common factor here is going to be 3x squared y squared. You can see that 3 is common to both sides. Now x squared is common to both sides as well. And y squared is common to both sides. So we have 3x squared y squared. Now if we divide 6x squared y cubed by 3x squared y squared, 6 divided by 3 results in 2. X squared cancels x squared, and y squared cancels out 2y here to leave us with 1, so 2y. And if we have minus 3x cubed y2, and we divide that by 3x squared y squared, 3 cancels out 3. X squared cancels out 2 x's here to leave us with 1x, and y squared cancels out y squared. So we're left with minus y. Minus x rather. So that's the answer to that. And that's how we do factorizations that involves binomial. But we can also have expressions that have 4 terms in them, such as 2x plus 8 plus bx plus 4b. And we can be requested to factorize this as well. Now, if you notice that each of these terms have things in common, like 2x and 8 have 2 in common, bx and 4b have b in common. In cases where you have 4 terms and like terms are not grouped, you need to rewrite the expression to group the like terms and then go ahead with the factorization. In this case, they are already grouped, so we can go ahead with our factorization. And this is going to result in 2 is a common term between these two. So 2x divided by 2 is going to result in x, and 8 divided by 2 is going to result in 4. In this case, b is a common term, so b is outside the bracket. Bx divided by b is going to result in x, and 4b divided by b is going to be resulting for x. But we're not done. We can also see that we have x plus 4 as a common term between these two. So we can write our x plus 4 also as a uniform term, and then 2 divided by, if you take 2x plus 4, which is what we have here, and you divide it by x plus 4, obviously this cancels out this and you're left with 2. So you have 2 here, and if you do the same thing here, you're left with plus b. And so this is the final factorization of this expression. If we have another example, such as 7x minus 21 minus xy plus 3y. Now to solve this, we can see that 7x and minus 21 have a common factor, 7. And so if you divide 7x by 7, you have x, and minus 21 divided by 7 results in minus 3. Now, minus xy plus 3y has a common factor of minus y. Minus xy divided by minus y, and that's going to result in x, and 3y divided by minus y is going to result in minus 3. And so as you can see from here, by now you know that what we'll do is simply write out our common factor x minus 3, which is common to both terms here, and then simply write down the expression that is left, which is 7 minus y. And this is the final answer. So to solve this, 2xy minus x squared has x as a common factor. So 2xy minus divided by x is equal to 2y, and minus x squared divided by x is equal to minus x. 2y squared minus xy has y as a common factor. So 2y squared divided by y is equal to 2y, and minus xy divided by y is equal to minus x. So we know that 2y minus x is a common factor, and we can simply write down the remaining expression, which is x plus y. And that is the final answer. So the next thing we'll be looking at is factorization of quadratic equations. In this video, we'll be talking about the factorization of quadratic equations. And you'll recall that we had said quadratic equations or expressions are expressions with a degree of 2, which means that the highest power to which the variable is raised in such expression is 2. So they are usually in the form ax squared plus bx plus c. Now, when we factorize this expression, what we hope to get are two factors in the form x plus k and x plus h. These are going to be the factors we'll derive upon factorization of the quadratic equation. Now, if we expand these, what we'd have is x multiplied by x is x squared, x multiplied by h would be equal to hx, k multiplied by x is equal to kx, and k multiplied by h would be equal to kh. Now, we can continue by writing this as x squared. These two have x as a common factor, so we can factorize that by bringing x out as a common factor, and then we would have h plus k, and this will become kh. Now if you notice, this expression that we have here is actually in the form of this expression. So if we bring this down here, we would have ax squared plus bx plus c. Now don't forget that we derived this from our initial assumptions that this is the kind of factors we're looking for. So if you look at this, you can see that now ax squared is the same as what we have here. The only thing is the coefficient is 1 here. And bx is the same as what we have here. In this case, b is equal to h plus k, and c is equal to k multiplied by h. So in order for us to be able to break a quadratic expression into components to make out the factors that we're looking for, h and k here, we would have to manipulate the equation such that the final term is expressed as a product of two numbers which adds up to form the mid term. So we find a way to break down the final term into a product of two numbers, k and h, which when we combine them by adding them up or subtracting them gives us the factor b here. Now let's solve an example so that what we're saying becomes clear. Imagine an example where we have x squared plus 5x plus 6. Now in this case, our b is equal to 5 and our c is equal to 6. So what we want to do is we want to look for the factors of 6, which when we multiply would give us 6, but when we add up or subtract them would give us 5. So what are the factors of 6? So the factors of 6 equals 1, 2, 3, and 6. These are the 4 factors that 6 have. Now, how can we multiply any two of these to produce 6? So we can do that by 1 multiplied by 6 can give us 6. 2 multiplied by 3 can give us 6. Now, which of these two can we combine by adding them up or subtracting them to give us 5? Now, we can say 6 minus 1 can give us 5, or 2 plus 3 can give us 5. You can use either, but let's use 2 and 3. So let's rewrite that into this equation. So what we would have is, now we'll break this down to be x squared plus, this is going to be 2 plus 3, just like we have it here. So we've gotten our k and h. In this case, we've chosen 2 and 3 to be our k and h. So we would have 2 plus 3x plus 2 times 3. Now if we want, we don't have to, but I'm just writing out everything explicitly in this first example so that in subsequent examples we can go faster. Now if we rewrite this, we can have this to be x squared plus, now if we expand this, this is going to be 2x plus 3x. As we don't need to actually break this down, we can just write that as 6. Now this is exactly what we want. We want to be able to break this down into 4 terms so that we can factorize like we learned in the previous example. We know how to factorize 4 terms in an equation. So this is going to become, x is common to the first 2 terms here, so we write x down as our common factor. X squared divided by x is equal to x, and 2x divided by x is equal to 2. Now, we have 3 as a common factor between 3x and 6. So we go ahead. Now 3x divided by 3 is going to be equal to x, and 6 divided by 2 is equal to 2. And so we can see in this case that our final expression of factors is x plus 2 and x plus 3. You remember how we do this? X plus 2 is common to both sides, and we write down the remaining, which is x plus 3. Now these are the factors of this example here. But we may also be asked to express the roots. Now what the roots means is that if we have an expression x squared plus 5x plus 6 equal to 0, and we know that this is the final answer we have here, which is also going to be equal to 0. So we know that anything multiplied by 0 is equal to 0. So for this expression to be equal to 0, one of these two have to be equal to 0. Either x plus 2 is equal to 0 or x plus 3 is equal to 0. Because if either of them is equal to 0, then the entire expression is equal to 0. So either x plus 2 is equal to 0 or x plus 3 is equal to 0. And then if we explicitly solve for x using this, we can say that if we make x the subject of the formula here, subtracting 2 from both sides, we have that x is equal to minus 2 or x is equal to minus 3. So these are the roots. These are called the roots. These are the roots of the equation. These are the factors. These are factors while these are the roots. The roots are x is either equal to minus 2 or x is equal to minus 3. Now let's solve more examples. If we have x squared minus 10x plus 21 equals 0. Now to factorize this quadratic expression, let me rewrite this so it looks a little bit cleaner. Now if we have to factorize this expression, the first thing we do is write down the factors of the final term here, 21. And the factors of 21 are 1, 3, 7, and 21. What two numbers can we multiply to get 21? We can have 1 multiplied by 21, or we can have 3 multiplied by 7. Now that we have our k and h, which of these two, which combination of these two can we add or subtract to give us 10? 1 plus 21 is equal to 22. 21 minus 1 is 20. 1 minus 21 is minus 20. So this first combination does not work. But you can see here, if we had 3 plus 7, we can get 10. But be careful, what we have here is not plus 10. What we have here is minus 10. So the best way to combine 3 and 7 to give minus 10 is minus 3 minus 7. Minus 3 minus 7 equals minus 10. So that's how we can combine 3 and 7 to give us minus 10. So if we rewrite this expression, we'll have x squared minus 3x minus 7x plus 21 equals 0. So minus 3 minus 7 is the same as minus 10. We've not changed the value, the essence of this equation. We've only rewritten it in terms of factors of 21. So we can go ahead and do our factorization. For these two terms, x is a common factor. So we write our x squared divided by x is equal to x. Minus 3x divided by x is equal to minus 3. For these two terms, minus 7 is a common factor. Minus 7x divided by minus 7 is equal to x. And 21 divided by minus 7 is equal to minus 3. So our factors are x minus 3 and x minus 7. Those are our factors. And from now we can tell that our roots are x is equal to 3 or x is equal to 7. The next example is x squared minus 4x minus 5. So we have to write down the factors of 5. And 5 is a prime number, so the only two factors we have is 1 and 5. So this is actually quite easy. Now we know that we have to combine 1 and 5 in a way to give us minus 4. And so if you write how you can combine this, you can say 1 plus 5, definitely that's 6. 1 minus 5, that's minus 4. 1 minus 5 gives us minus 4. So you know that that's what you want. 1 minus 5 is equal to minus 4. And that's how you can combine these two to give you minus 4. And so we can rewrite this equation as x squared plus x minus 5x. Don't forget what we have here is plus 1 minus 5. So plus x minus 5x minus 5. And this is equal to 0. So between x squared and x is a common factor. And x squared divided by x is going to be equal to x. And x divided by x is going to be equal to plus 1. Now, between minus 5x and minus 5 is a common factor. And minus 5x divided by minus 5 is going to be equal to x. And minus 5 divided by minus 5 is equal to 1. And so our final factors are x plus 1, which is the common thing here, and the remaining part of the expression, which is x and minus 5. X minus 5. So our roots to this quadratic equation is equal to x is equal to minus 1 or x is equal to 5. Let me just clarify how we get this again. You know that x plus 1 is equal to 0 or x minus 5 is equal to 0. Just from here, we can tell that either of these two have to be equal to 0 for the entire expression to be equal to 0. And so if we make x the subject of the formula here, we subtract 1 from both sides, and that's going to be x plus 1 minus 1 equal to 0 minus 1. So minus 1 cancels out minus 1 to give us x, and this is equal to minus 1. In this case, if we subtract 5 from both sides, we have x minus 5. We add 5 to both sides because we're trying to get rid of this 5. So x minus 5 plus 5 equals 0 plus 5. And this cancels out this to leave x alone here. And we have 0 plus 5. So x is equal to minus 1 or x is equal to 5. I hope that's clarified. For more, you can watch the video on change of subject of the formula to be clearer on this. What we've learned so far is factorizing a quadratic equation where the coefficient of the first term is 1. What about in a case like this where the coefficient is not 1? But in this case, what we would do is we would multiply the coefficient of the first term and the constant term. So in this case, 3 times 4 is going to be equal to 12. Now we'll write out the factors of 12, which are 1, 2, 3, 4, 6, and 12. And then these factors are what we would be using. And so we can combine these factors in the way 1 times 12 equals 12, 2 times 6 equals 12, and 3 times 4 equals 12. So we have to combine one of these sets of numbers to derive 8. And obviously the set that qualifies is 2 and 6. So we would have to rewrite this expression as 3x squared plus 6x plus 2x plus 4 equals 0. And so this can be factorized into 3x squared plus 6x has 3x in common. So 3x squared divided by 3x is x, and 6x divided by 3x is equal to 2, plus 2x and 4 have 2 in common. So 2x divided by 2 is equal to x, and 4 divided by 2 is equal to plus 2. And so our factors are x plus 2 and 3x plus 2 equals 0. Now in this case, the roots are going to be, here it's simple, x is equal to minus 2. And in this case, we would have 3x plus 2 equals 0. We're trying to make x the subject of the formula. So if we subtract 2 from both sides, we would have 3x equals minus 2. And then to make x the subject of the formula here, we just divide both sides by 3. So we'll have x equals minus 2 over 3. So for this other case, x is equal to minus 2 over 3. So these are the roots of this equation. Let's do another example. If we have 6y squared plus 13y plus 5. Now, we do the same thing, multiply the coefficient of the first term by the constant factor, which is going to be 6 times 5, and that's 30. So we write down the factors of 30, which is 1, 2, 3, 5, 6, 15, and 30. So we can combine these factors by 1 multiplied by 30 gives us 30. 2 multiplied by 15 gives us 30. 3 times 10. Okay, I missed out 10 here. Excuse me. 5 times 6. So the rational choice to use would be 3 and 10. And so if we rewrite this, we would have that 6y squared plus 3y plus 10y plus 5 equals 0. I omitted that here. So we can factorize 3y from here. This is going to be equal to 3y into 6y squared divided by 3y is going to be equal to 2y plus 3y divided by 3y equals 1. And in this case, 5 is common to both terms here. So 5, 10y divided by 5 is equal to 2y. And 5 divided by 5 is equal to 1. So our final expression of fractions is going to be equal to 2y plus 1, 3y plus 5 equals 0. And so the roots here is going to be equal to y equals minus 1 over 2, or y equals minus 5 over 3. So if we have 8x squared plus 18x minus 5, now 8 multiplied by 5 is equal to 40. So 40. Factors of 40 include 1, 2, 4, 5, 8, 10, 20, and 40. So the factors can be combined such that 1 multiplied by 40 gives us 40. 2 multiplied by 20 gives us 40. 4 times 10. 5 times 8. What else? 20 times 2. We already have that. 5 times 8. And those are the combinations that we can get. So which of these combination can give us 18? 2 and 20 can be added to give us 18. And if you check through, you'd notice that that's the only choice we have. So the best way to position that to make sense here would be 8x squared minus 2x plus 20x minus 5 equals 0. And minus 2x plus 20x gives us 18. So we're not changing the essence of this equation. So if we continue with that, 2x is common to these two terms. So we have 2x right here. And 8x squared divided by 2x is equal to 4x. And minus 2x divided by 2x is equal to minus 1. And in this case, we have 5 to be a common term. So 20x divided by 5 is equal to 4x. And minus 5 divided by 5 is equal to minus 1. And so our factors are 4x minus 1 and 2x plus 5. And so the roots of this quadratic equation is x is equal to 1 over 4 and x is equal to 5 minus 5 over 2. So that's how you factorize quadratic equations, looking for the factors as well as the roots. Okay, we've learned how to factorize quadratic expressions, but not all quadratic expressions can be split into factors. And before we go through the whole the stress of the mathematical computation, we can actually apply a test that can tell us upfront if a quadratic equation can be split into simple factors or not. And that test is simply solving this expression, b squared minus 4ac. Now, if the result you get from this is a perfect square, then yes, the quadratic equation can be split into factors. If it's not a perfect square, then you cannot split the quadratic equation into two factors. So let's do some examples so we understand. We know that quadratic equations are in the form ax squared plus bx plus c. And so all we have to do is substitute the a, b, and c's here into this and then solve. So let's look at these two examples, 7x squared minus 3x minus 5 and 3x squared plus x minus 4. We want to find out if these quadratic equations can be split into factors or not. So here, 7, a equals 7, b equals minus 3, and c equals minus 5. So if we put that into b squared minus 4ac, what we have is b squared is minus 3 squared minus 4, a is 7, and c is minus 5. And so minus 3 squared is equal to 9, minus 4 times 7 is 28. 28 times minus 5 is equal to minus 140. Now, 9 minus times minus is equal to plus, so this is 9 plus 140. And this results in 149. Now, the square root of 149 is equal to 12.207. And so here we can tell that this is not a perfect square. And so by that we can tell that this particular quadratic equation cannot be expressed in terms of simple factors. But what about this one? In this case, a equals 3, b equals 1, and c equals minus 4. So if we substitute that into b squared 4ac, b squared minus 4ac, we have b squared to be 1 squared minus 4 multiplied by 3 multiplied by c, which is minus 4. So this is going to be 1 minus 4 times 3 is 12, and 12 minus 4 is minus 48. So this is going to be equal to minus times minus is equal to plus, so 1 plus 48. And this is finally equal to 49. Now the square root of 49 is 7. So this is a perfect square. And in this case, this expression can actually be resolved into simple factors. So that's just a simple way of testing from the onset if the expression that we have can be split into simple factors or not. The next thing we'll be talking about is the factorization of cubic polynomials. Now before we do this, we should go over a couple of things. The first one being the remainder theorem. Now the remainder theorem simply states that if a polynomial f of x is divided by a binomial x minus a, the remainder is equal to f of a. What this theorem is simply saying is that if we have a polynomial f of x and we divide this polynomial by a binomial x minus a, now in this case, because we're dealing with a cubic polynomial, we're bound to have a solution which is in the quadratic polynomial form, x squared plus bx plus c. But then we would also have a remainder which this theorem proposes is going to be equal to f of a. So we have our f of x. If we divide it by x minus a, we would have a solution which is a quadratic polynomial, and then the remainder is going to be of the value f of a. Now let's do some examples to prove this theorem. So if we take for an example our f of x to be equal to x cubed minus 5x squared minus 2x plus 24, and we assume a to be equal to 2. It's just an example. Let's assume a to be any number. In this case, we choose 2. So x minus a, which is our binomial here, is going to be equal to x minus 2. So if we evaluate f of a, now to evaluate f of a, all we need to do is simply replace all the x's in our polynomial by 2, which is equal to a. So 2 cubed minus 5 multiplied by 2 squared minus 2 into 2 plus 24. So f of a is equal to 2 cubed is equal to 8. 2 squared is equal to 4 multiplied by 5, that's 20. Minus 2 times 2 is equal to 4 plus 24. So f of a equals 8 minus 20 is minus 12, Minus 12 minus 4 is minus 16. Minus 16 plus 24 is equal to 8. So what we've seen here is saying that our remainder f of a is 8. So to test out the theorem, what the theorem is saying is that if we divide our main polynomial here, if we divide it by x minus 2, we should get a remainder of f of a, which is going to be equal to 8. So let's try that out here. We have x cubed divided by x is equal to x squared. X squared multiplied by x is equal to x cubed. Now, x squared multiplied by minus 2x is equal to minus 2x squared. If we subtract everything in this bracket, we have x cubed minus x cubed. That cancels out itself. And we have minus 5x squared minus 2x squared. So minus times minus becomes plus, and minus 5x squared plus 2x squared becomes minus 3x squared. So we bring down the next term here, which is minus 2x. Minus 3x squared divided by x is equal to minus 3x. So minus 3x multiplied by x is equal to minus 3x squared. And minus 3x multiplied by 2 is equal to plus 6x. So minus 3x squared plus 3x squared cancels out itself. And minus 2x, this becomes minus 6x, results in minus 8x. We bring down the next term, which is plus 24. Minus 8x divided by x, that's going to be equal to minus 8. Minus 8 multiplied by x is equal to minus 8x. And minus 8 multiplied by minus 2 is equal to plus 16. So minus 8 plus 8x cancels out, and then minus times plus becomes minus. So this is plus 24 minus 16, and that's going to result in 8. So we can see that, as the theorem said, if you divide f of x by a binomial x minus a, which in this case is 2, x minus 2, you will get a remainder 8, which is going to be equal to our f of a. Now the question is, how does this help us get the factors for a cubic polynomial? And to understand that, we need to understand the factor theorem. And simply speaking, what the factor theorem is saying that is that the polynomial x minus a is a factor of the polynomial f of x if and only if f of a is equal to 0. So if we have a polynomial f of x and you divide it by x minus a, in this case, the factor theorem is saying is that if x minus a is a factor of f of x, then you're going to get a solution x squared plus bx plus c, but this time your remainder has to be 0. And that's a simple thing to reason, because if you imagine a random number like, let's say 20, if you divide 20 by, let's say 6, 20 divided by 6 will result in 3 remainder 2, because 6 is not a factor of 20. So if 6 is not a factor of 20, you are bound to have a remainder. But if you divide the same 20 by 4, which is a factor of 20, you would get 5 and a remainder of 0. So simply speaking, what the factor theorem is saying is that if you divide f of x by x minus a, and if x minus a is a factor of f of x, then you are going to get a remainder of 0. So if we follow the remainder theorem, we know that the remainder theorem says that if we have f of a, this is going to be equal to the remainder that we have. So what we need to do to find the first factor of a polynomial is to find an a, which if we express the f of a, would give us 0. So let's solve an example. So if we're asked to factorize x cubed plus 6x squared plus 5x minus 12, this is our f of x. So the first thing we do is actually guess a value of a such that if we evaluate f of a, this is going to be equal to 0. So if we assume first and foremost that a equals 2, So let's express f of a. F of a is equal to 2 cubed plus 6 2 squared plus 5 into 2 minus 12. So f of a is equal to 2 cubed is equal to 8 plus 2 squared is equal to 4. 4 times 6 is equal to 24. 5 times 2 is 10 minus 12. Now this is equal to 8 plus 24 is 32. 32 plus 10 is 42. 42 minus 12 is equal to 30. So f of a is not equal to 0. So in this case, a is not equal to 2. That's not what we're looking for. So we have to try another number. If we try out a equals 1, f of a equals 1 cubed plus 6 into 1 squared plus 5 into 1 minus 12. So f of a equals 1 cubed is 1 plus 1 squared is 1 multiplied by 6 is 6 plus 5 minus 12. So 1 plus 6 is 7. 7 plus 5 is 12. 12 minus 12 is equal to 0. Definitely a equals 1. So our value for a that we're actually seeking is 1. So x minus a is equal to x minus 1. So we know our first factor. X minus a is our first factor for this polynomial. Now how do we get the other two factors? Because for a cubic polynomial, we're expecting to have 3 factors. Now to get the other factors, the next step is to divide this polynomial by the first factor that we've guessed. So if we do that, we'll have that x cubed divided by x is equal to x squared. X squared multiplied by x is equal to x cubed. X squared multiplied by minus 1 is minus x squared. So we subtract everything here. X cubed minus x cubed cancels out, and minus times minus is plus, so this becomes 6x squared plus x squared, and that's 7x squared. So we bring down the next term, which is plus 5x. So 7x squared divided by x, that's going to be equal to 7x. 7x multiplied by x is equal to 7x squared, and 7x multiplied by minus 1 is equal to minus 7x. So if you subtract everything here, 7 squared minus 7 squared cancels out, and minus times minus becomes plus. So this is plus 5x plus 7x, and that's equal to 12x. We bring down the next term here, which is 12. 12x divided by x, that's plus 12. So 12 multiplied by x is equal to 12x. 12 multiplied by minus 1 is equal to minus 12. Now these two are the same, so subtracting them would result in 0. So we have our new factors to be x minus 1, which is the first one we've gotten, and next one is x squared plus 7x plus 12. So the next thing to do is, here we have a quadratic polynomial. So we have to factorize this quadratic polynomial to get the final factors. And to do that, we find the factors of 12, which if we add up would result in 7. And ordinarily we can think about 4 and 3. So if we break this down, this can be written as x squared plus 4x plus 3x plus 12. And if we factorize that, x squared plus 4x has x in common. So x squared divided by x will be equal to x plus 4x divided by x is 4. These two have 3 in common. So 3x divided by 3 is x, and 12 divided by 3 is equal to 4. So our factors from the quadratic factor here is x plus 4, x plus 3. So now that we've succeeded in breaking that down into simpler factors, our factors for the original polynomial that we started is, the first one that we we're able to guess out, which is x minus 1, and the 2 that we derived from our division, which is x plus 4x plus 3. So these are the factors of the polynomial, and our roots are x equals 1, x equals minus 4, and x equals minus 3. These are the roots of the polynomial. And that's how you get the factors for your cubic polynomial. The first step is to guess a number for a, which results in f of a being equal to 0, and then helps us to express the first factor x minus a, which is what we have here as x minus 1. And then we divide the original polynomial by the first factor that we've guessed, which will result in a quadratic polynomial. And then we can split our quadratic polynomial into 2 factors. And our 3 factors for the cubic polynomial are the 2 factors of the quadratic polynomial and the first one that we've guessed as expressed here. Let's try another example so we're super clear. So if we have 2x cubed plus 9x squared minus 11x minus 30. Now, first we have to get a value for a such that f of a is equal to 0. Now, there's no rule for guessing this, but I would advise that you start with with 1, and then based on the result you get, you know if to reduce it or to increase it. But I've done for this, and I can tell you for sure that the a is equal to 2. So let's see if f of a with a being equal to 2 gives us 0. So that will be 2 into 2 cubed plus 9 into 2 squared minus 11 into 2 minus 30. So f of a, 2 cubed is 8. 8 multiplied by 2 is equal to 16. 2 squared is equal to 4. 4 multiplied by 9 is equal to 36. Minus 11 times 2, which is 22, minus 30. 16 plus 36 is equal to 52. 52 minus 22 is equal to 30. And 30 minus 30 is equal to 0. So a equals 2, as I've said. And the value of x minus a is equal to x minus 2. So we have our first factor, x minus 2. Now to find the other 2 factors, what we have to do is divide 2x cubed plus 9x squared minus 11x minus 30. We have to divide that by x minus 2. So 2x cubed divided by x is equal to 2x squared. 2x squared multiplied by 2x is equal to 2x cubed, and 2x squared multiplied by minus 2 is equal to minus 4x squared. So if we subtract everything in this bracket, we have that 2x cubed minus 2x, that cancels out, and then minus times minus becomes plus. So this is 9x squared plus 4x squared, and that's equal to 13x squared. So we'll bring down the next term here, which is 11x. 13x squared divided by x, that's equal to plus 13x. 13x multiplied by x is equal to 13x squared. 13x multiplied by minus 2 is equal to minus 26x. So if we subtract everything here, 13x squared minus 13x squared cancels out. And then minus times minus is plus. So this becomes minus 11x plus 26x. And that's going to be equal to 15x. And then we bring down the next term, which is minus 30. 15x divided by x, that's equal to plus 15. 15 multiplied by x is 15x. 15 multiplied by minus 2 is equal to minus 30. So if we subtract this, obviously they are equal, so this leads to 0. So our new factors are x minus 2, which is the initial one that we had guessed, and 2x squared plus 13x plus 15. So the next thing we have to do is to factorize this quadratic equation. And to do that, we have to multiply 2 by 15, that's 30. So we have to look for the factors of 30, which if we combine will be able to give us 13. And obviously I would suggest 3 and 10. So if we do that, we can rewrite this to be equal to 2x squared plus 3x plus 10x plus 15. So these two have x in common. So that's going to be x. 2x squared divided by x is equal to 2x. 3x divided by x is 3. These two have 5 in common. So 10x divided by 5 is equal to 2x. And 15 divided by 5 is equal to 3. Our final factors for this quadratic polynomial is 2x plus 3 and x plus 5. So finally, we can tell that our factors for the original cubic polynomial are x minus 2, 2x plus 3, and x plus 5. These are our factors. And the roots are x is equal to 2, x is equal to minus 3 over 2, and x is equal to minus 5. So if we have 3x cubed minus 4x squared minus 28x minus 16, the first thing we need to do is guess a value for a such that f of a is equal to 0. And the value of a that would make f of a equal to 0 here is minus 2. So let's try f of a with a equals minus 2. So if we have that, we have 3 into minus 2 cube minus 4 into minus 2 squared minus 28 into minus 2 and minus 16. Minus 2 cubed is minus 8. Minus 8 multiplied by 3 is equal to minus 24. Minus 2 squared is equal to 4. 4 multiplied by 4 is equal to 16. Minus 2 multiplied by 28 is equal to minus 56. And so that's going to make this one plus 56. And then minus 16. So if you sum this up, you have that minus 24 minus 16 is equal to minus 40. Minus 40 plus 56 is equal to 16. And 16 minus 16 is equal to 0. So a equals minus 2. So x minus a is equal to x minus minus 2. And that means that our first factor is equal to x plus 2. So x plus 2 is our first factor. Now, having learned that, so the next thing to do is to divide our original polynomial 3x cubed minus 4x squared minus 28x minus 16 by x plus 2. So if we do that, 3x cubed divided by x, that's going to be equal to 3x squared. So 3x squared multiplied by x is equal to 3x cubed. And 3x squared multiplied by 2 is equal to plus 6x squared. So if you subtract everything here, you have 3x cubed minus 3x cubed cancels out. And minus times plus is equal to minus. So this becomes minus. So minus 4x squared minus 6x squared is equal to minus 10x squared. If we bring down the next item here, that's minus 28x. Minus 10x squared divided by x, that's going to be equal to minus 10x. So minus 10x multiplied by x is equal to minus 10x squared. And minus 10x multiplied by 2 is equal to minus 20x. So if we subtract everything here, this becomes plus. So minus 10x plus 10x squared cancels out. And minus times minus becomes positive. So minus 28x plus 20x becomes minus 8x. Now if we bring down the next term here, that's minus 16. Minus 8x divided by x, that's going to be equal to minus 8. Minus 8 multiplied by x is equal to minus 8x. And minus 8 multiplied by 2 is equal to minus 16. So if you subtract these two, because they are equal, you have 0. Our new factors are x plus 2 and 3x squared minus 10x minus 8. We have to factorize this quadratic expression to be able to get our remaining two factors. And to do that, 3 multiplied by 8 is equal to 24. So we have to find the factors of 24, which if we add or subtract will give us 10. And you can think of 2 and 12. So if we rewrite this expression, we have 3x squared plus 2x minus 12x minus 8 plus 2x minus 12 gives us minus 10x, so we're good. So if these two have x in common, so 3x squared divided by x becomes 3x, and 2x divided by x becomes 2. These two have minus 4 in common. Minus 12x divided by 2 results in 3x, and minus 8 divided by minus 4 becomes plus 2. So our factors from the quadratic equation, or for the quadratic polynomial, are 3x plus 2 and x minus 4. So all our factors are x plus 2, which is the first one that we had guessed, and these two that we had derived from our division, which are 3x plus 2, x minus 4. These are our factors. And our roots are x equals minus 2, x equals minus 2 over 3, and x equals 4. These are our roots. Thank you for watching the video. I hope you've been able to understand everything that we've gone through. If you like the video, please subscribe to the channel, turn on the notifications, and tell someone about this channel. See you in the next one.